Welcome all. In the last class, we discussed about the support vector machine. So, why it is needed? So, what is support vector machine? So, we dealt with the introductory part of the support vector machine, and we have also seen what is the SVM model. In today's class, we are going to discuss the one more most critical part and the most important part in the support vector machine, that is the kernel function. So, today we are going to see what is kernel function, so how the kernel function appears and what are the advantages and disadvantages of the support vector machine. We know that support vector machine is a classifier. The aim of every classifier is to predict the classes correctly. Most of the time it is very rare to have a data that is very simple and it is easily separable. Most of the time it is very rare condition that we are getting a linearly separable data. So what we do is, when we have a non-linearly separable data, so we convert the data into higher dimension and then we try to classify it with the SVM. So what we do is, we convert the given data set to higher dimension feature space and make data almost linearly separable. For example, the one dimensional data set can be transformed to a two dimensional or a polynomial through a polynomial mapping. But the most important thing here is, when we transform from one dimension to another dimension, a lot of data manipulation is to be made. So to avoid that, we use the kernel function. The magic of the kernel method is, it finds a function that avoids all the trouble implied by the high dimensional computation. So the result of kernel is a scalar or a one dimensional space. So that's why the kernel methods are the most widely accepted methods for transforming from one dimensional space to another dimensional space. So that's the most important concept in the support vector machine, because support vector machine is the most highly advanced classifier, so that can be that is more rigorously classifies using the kernel function. So let's look at some of the important points. So kernel method is the heart of the support vector machine algorithm, and that is the kernel. The most kernel algorithms are based on optimization in convex space and are statistically well founded. So all the kernel algorithms are based on the optimization technique and they are well proven. So kernel is the core or germ in a fruit. Kernel methods operate using the kernel tree. The trick involves computing and working with the inner products of only the relevant pairs of data in the feature space. So here we are considering only the relevant pairs of the data in the feature space. We do not, that is kernel do not need to compute all the data in a high dimensional feature space. So only the relative data are being computed. The kernel trick makes algorithm much less demanding in computational and memory resources. Kernel method achieve this by learning from instances. So since kernel trick uses only relevant pairs of data, so hence the computation demand is very less and a less memory resource is needed. So kernel methods are a type of instance based learning. So they learn from the instances. Kernels do not apply standard computational logic to all the features of each input. Instead, they remember each training example and associate a weight representing its relevance to the achievement of the objective, and this is called instance based learning. So normally the kernel functions they do not apply a common formula for all the computation feature, for all the features of the input. What they do is, so they remember the training example and they assign a specific weight to each of the feature, and based on its relevance it is going to achieve the classification. That is nothing but the instance based learning. Several types of support vector machines exist. Some are linear, polynomial, radial basis function, and some are sigmoid. So this is similar to how human beings learn, especially about domains with broad set of features such as ethics. So what is the human nature of learning the things? So we learn from tough situation and discard the normal instances. In kernel method, we assign high value to the abnormal situation and very low weight to the normal situation. For example, the same thing what we do is, we always try to learn from the difficult situation, and because when we learn from the difficult situation, so we can handle the easy situation with a very simple. So the same way kernel methods also assign high weights to the abnormal situation and very low weight to the normal situation. So sometimes the normal situation may be discarded. Support vector machines are more flexible and tolerate to data misclassification. So support vector machines are they are more flexible, means they can be applied to more kinds of data, and they can tolerate some amount of misclassification. The margin of separation between categories is a soft margin as against the hard margin. So there is a soft margin, means where there is a that indicates there is a some tolerance between the classification or the classified data values. That's the most important thing with respect to the kernel. So let's look at one simple example regarding the kernel. So let's go with a mathematical definition of kernel. K x comma y equal to f of x comma f of y. So here k is the kernel function and x and y are n-dimensional inputs. F is a mapping from n dimension to m dimension space. X comma y in angular bracket denotes the dot product. So we know that this represents the dot product. Usually m is much larger than n. So what here we have is, we have a kernel function x comma y which are in n dimension, and we need to transform this n dimension to m dimension through the mapping f. Normally calculating f of x and f of y, that is dot product, requires to find first fx, fy and then do the dot product. First we need to find what is f of x and f of y. So first we need to transform the given x comma y to the m dimension space, and then we need to find the dot product. So these two computations are very expensive because they involve manipulation in m dimensional space where m can be a large number. But after all the trouble of going to the high dimensional space, the result of the dot product is a scalar. We know that dot product always gives a scalar and cross product gives a vector. We come back to one dimensional space again. So that's the most important thing. We transform the high dimensional values, we transform from one dimension to another for our simplification. Now what we do have is, do we really need to go through all this trouble to get this one number? So to get a single scalar value, so is it necessary to perform all the transformation from n dimension to m dimension and finding the dot product? So that is why there comes into picture the play of kernel methods. So let's take a small example. So here x is given by 3 values, x1, x2, x3, and y is given by 3 values, y1, y2, y3. Then for the function f of x, we define the function f of x as x1 into x1, comma x1 into x2, comma x1 into x3, comma x2 into x1, x2 into x2, x2 into x3, x3 into x1, x3 into x2 and x3 into x3. So, the kernel here is the x comma y, that is the dot product whole square. So, let us plug some numbers and make this more understandable. Suppose I have x equal to 1, 2, 3 and y equal to 4, 5, 6. So, first let us find what is f of x. F of x equal to, see here, x1 is 1, x2 is 2, x3 is 3. So, let us substitute the values of x1, x2, x3 in this equation f of x. What we will get, x1 into x1, that is 1 into 1, so answer is 1. Then 1 into 2, x2 is 2, answer is 2. 1 into 3, answer is 3. Next, coming to second, x2 into x1, 2 into 1, so answer is 2. 2 into 2, answer is 4. 2 into 3, answer is 6. Then x3. So, what is x3? x3 is 3 into 1, that is 3, 3 into 2, that is 6, and 3 into 3, that is 9. So, that is how we get the values of f of x. Similarly, we compute the value of f of y. So, we replace wherever x with the y. So, y1 into y1, y1 into y2, y1 into y3, y2 into y1, y2 into y2, y2 into y3, y3 into y1, y3 into y2 and y3 into y3. So, let us plug these y values in the f of y. So, what is f of y? So, 4 into 4, 16, 4 into 5, 20. So, because y1 is 4 and y2 is 5, 4 into 5, 20, then 4 into 6, 24. So, that is how we got 3 values. Then y2 into y1, so 5 into 4, 20, then 5 into 5, 25, then 5 into 6, 30. Next, again 6 into 4, 24, 6 into 5, 30, 6 into 6, 36. Now, we got f of x and f of y. So, our next job is to find the dot product of the f of x and f of y. So, what is dot product? So, it is nothing but the multiplication of the individual values. So, multiply 16 into 1, we get 16. We multiply each of the values and we add all the resulting values. 16 into 1, 16, 20 into 2, 40, 24 into 3, 72, 24 into 20 into 2, 40, 25 into 4, 100, 30 into 6, 180, 24 into 3, 72, 30 into 6, 180 and 36 into 9, so that is 324. So, after adding all these, so we get 1024 and this is nothing but the dot product of the given values. So, that is f of x, f of y, the dot product of f of x and y is the 1024. Now, what we did is, so we mapped this 3-dimensional space into a 9-dimensional value, that is f of x. So, 3-dimensional x is mapped into 9-dimensional function through f of x. Now, is there any shortcut method so that can minimize all the computations that we perform? So, is there any shortcut method to get this 1024 by eliminating some of the steps, and that is provided by the kernel function. So, a lot of algebra is involved. So, mainly because f is a mapping from 3-dimensional to 9-dimensional space. Now, suppose if I use the kernel function, so what is the kernel function? One of the standard kernel function is, so xi into yi, if xi into yi, so just take the dot product of this and square it, we get a polynomial kernel. So that is how we got 4 plus 10 plus 18 square equal to 32 square, and that is 1024. If we look at the computational complexity involved here as compared to computational complexity involved at this place, so it's very large. So here it's very simple, the calculation is very simple. Now how we got these values? 4 plus 10 plus 18, so just multiply 1 with 4, we get 4, 2 with 5 with 10, 3 into 6, 18 whole square. So that is how many functions we have, how many inputs we have, x and y, so hence it is 2. So that is a polynomial kernel, a kind of polynomial representation for the kernel. So that this type of simplification is provided for most of the data sets with the help of the kernel method. So that is how the kernel method simplify the task of classification. Let us see what are the standard classification kernel methods for the classification like this. So we have some standard kernel functions like k of xi comma xj equal to xi into xj plus 1 raised to p, where it is called a polynomial kernel. So xi, k of xi xj equal to e to the power minus 1 by 2 sigma square xi minus xj whole square, it is called Gaussian kernel, and it is a special case of a radial basis function. Then we have k of xi comma xj e to the power minus gamma xi minus xj whole square, which is called the RBF kernel, that is radial basis function kernel. So then next we have k of xi comma xj equal to tan hyperbolic eta xi into xj plus v, that is a sigmoidal kernel, so which is an activation function for the neural networks. So that is these are the commonly used kernel to transform the data from one dimensional space to another dimensional space. So that reduces the computation complexity involved with the normal function. Now let us see what are the advantages and disadvantages of support vector machine. Support vector machine works well when the number of features are much larger than the instances. Suppose if I have 100 features and only 50 data values, so then also the support vector machine works perfectly, because it can work on huge data set, which is the case in spam filtering, where large number of words are the potential signifiers of a message being spam. Even when the optimal decision boundary is a non-linear curve, the support vector machine transforms the variable to create new dimensions such that the representation of the classifier is a linear function of those transformed dimensions of the data. So that is what we convert from one dimension to another dimension in case of non-linear data set. Then SVMs are easy to understand. So they create an easy to understand linear classifier by working on only a subset of the relevant data, and it is computationally efficient. So they, since in the beginning only we have said they will not use a standard computational logic on all the features, they will just select only relevant pairs, and based on that they will assign the heavy weights, and then they will perform the classification. So hence they are computationally efficient. So there are some limitations associated with the support vector machines, and that is they work well only with the real numbers. So only for the numerical data support vector machine works perfectly. So all the data points in all dimensions must be defined by numeric values. It does not work with any of the categorical, ordinal, nominal values. So it needs only the numerical data. It works only with the binary classification problem. So one can make a series of cascaded SVMs to get around this constraint. So sometimes this support vector machine, it works only for the binary classification. So means when we want to divide when we have only two classes, in such cases we use the support vector machine. So training the support vector machine is an inefficient and time consuming process when the data is large, because when the data becomes large, so we need to find the relevant pairs on which we need to perform the computation. So that is one of the difficulty in the support vector machine. It doesn't work well when there is much noise in the data and thus has to compute the soft margin. So when the data contains a lot of noise, means if there are some outliers present or if some of the values are missing in the data, then in such cases the support vector machines are very vulnerable to misclassification, and yes, they compute the soft margins. So means where they can tolerate some misclassification. Okay. So that is one of the limitation of the support vector machine, but in totality support vector machines are the most advanced and they are most state of the art classification technique for the data set. Okay. So what we can summarize is, so support vector machine is a supervised machine learning model that uses classification algorithm for two group classification. So two group classification is very important because it is working only for the binary classification. Okay. So that's for the today's class. Thank you.